Welcome to second series of video lectures on current electricity. In this video we're going to talk about charge and current. So first, the charge. So we find charge in the form of an electron or in the form of a proton in an atom, and both electrons and proton have the same one electron has the same charge but different sign. So one electron has minus 1.6 into 10 power minus 19 coulomb. This is something you must remember. And one proton has plus 1.6 into 10 power minus 19 coulomb. So since you can have either 2 electron or 3 electron or 4 electron, and you cannot have 1.25 electrons, because this is a fraction. 1.25 is a fraction. So we can say that, hey, these are the following valid charge configuration. So you can have 2 into 1.6 is 3.2 into 10 power minus 19 coulomb. That is 3 into 1.6 into 10 power minus 19 is 4.8 into 10 power minus 19 coulomb. You can have 4 into 1.6 into 10 power minus 19. That's 6.4 into 10 power minus 19 coulomb. Of course, these are all plus or minus, so it doesn't really matter if it's an electron or a proton. But what is not possible is 1.25 electrons. So this is not possible. 1.25 into 1.6 into 10 power minus 19. That's 2 into 10 power minus 19 coulomb. So this is not possible, while everything else is possible. So this is what we mean by quantization of charge. So we usually say, hey, Q is plus or minus NE, where N is an element of I, which means that it can take 0, 1, 2, and so on. So this is the principle of quantization of charge. Moving on to the next topic of what is a current, it is best understood through an example. So moving to a simulation. Here is a simulation of a current of a battery connected to a circuit. So we can see what the current would be by adding an ammeter into the circuit. So let's try to add the ammeter. So this is, I delete this and I connect an ammeter to so here's an ammeter connected to the circuit. So it shows 0.9 amps. Now let's see what this really means. So here is a symbolic representation of the previous circuit. So this is your resistance, bulb, battery, and this is your ammeter. We call it ammeter. Now it shows what your current is. Here it shows 0.9 amperes. So 0.9 amperes implies that the amount of charge which moves through a cross section, let's say this cross section is AB, a thin cross section. So 0.9 ampere implies there is 0.9 coulomb that per second that passes through AB, passing through AB, right? Passing via AB. So that is a definition of current. So usually it is written as I is equal to dq by dt. So in a small amount of time dt, you're basically seeing how much coulomb is passed. So this is nothing but unit of current would be coulombs per second. In SI unit, we say it is amperes. So I hope this video was interesting for you, and you have gained some idea on how to view charge and current. In the next video we're going to look into the concepts of potential difference and resistance. Until then, see you. Bye.